Good morning, good afternoon, and good evening, everyone. As Jose mentioned, my name is Erin O'Brien. I am the Executive Director of CSDA, the Concrete Sawing and Drilling Association. We are a US-based association, but we have members from all over the world, including many IACDS members. So welcome and thank you for joining us. SLURRY Solutions is a member of CSDA, so I've partnered with Mark today to help give this webinar. Mark is the expert on slurry here in the US, and CSDA is here to just provide a little support and talk to you about some of the resources we can offer. We are the only association promoting and advancing the industry of concrete renovation here in the US. We have about 500 member companies. Our focuses are safety, training, and networking. We have a variety of standard specifications and best practices to offer on many subjects, and many of those have been developed in conjunction with IACDS. We're happy to partner with them on some of our documents. The association has been around since 1972, and we are about to celebrate our 50th anniversary next year, which we're very excited about. And so we hope that if you are able to, that you may be able to join us for our annual convention, which will take place next March and April in Bermuda, which is a convenient direct flight from London. If you're over there in Europe, we'd love to have you join us. Our conventions are a great opportunity for networking and education. And we are thrilled to be part of this webinar. We will discuss some of the resources CSDA can provide to IACDS members and CSDA members at the end of this webinar, and I will be available for any questions you may have. Thank you, Jose, and turn it back over to you.
Thank you, Erin. Thank you for the introduction, and thank you also for being available and making this possible, because it was through CSDA that we reached out to Mark. I kindly ask Mark now to turn on the camera and the mic. And Mark, if you want to introduce yourself, I leave the floor to you.
Good morning and afternoon. My name is Mark Critchfield. I'm the owner of SLURRY Solutions out of the United States. We've been doing this about 8 years, and it's been quite an evolution on the products and processes and techniques that have developed over the last few years. This actually began with one of your members, Gold's Company, and their filter press. It really sparked an interest with me in slurry management. So with this and the knowledge and development of the flocculants and the solidification agents and the other products that we'll talk about, we'll give you some ideas on what some of the U.S. contractors are doing and some new ideas you might want to try, and possible risk avoidance as far as disposal of the slurry on the job sites. I don't know if you're going to read the questions or if I'm going to read.
Just go ahead, Mark. We don't need to read the questions. Just
okay.
On your own.
Okay. First question: what is slurry? It's a mix of the concrete residue. We've got stone and sand fragments. There is quite a bit of admixture chemicals that might be a part of the concrete, and there's obviously the contaminants. We've got to make note of the contaminants that might be in the joints are actually in the cement material. So as we're sawing and exposing your workers and your equipment to these contaminants, we've got to make note. How is slurry generated? It's obviously blade and bit cooling. We want to continue to train our operators about water control during the sawing and drilling process. We really should try to reduce the gallons per minute flow to the blades. It's very typical to overuse the water in the sawing and drilling application. There is a good technique that we can use. If you can redirect your water hoses instead of spraying directly onto the blade, if you can come into the blade surface near the arbor and allow the water to come down the blade core, you get a lot less bounce off the water, off the core. Why is water used in cutting? It's dust suppression to reduce the airborne silica exposure to the saw operator and the other trades. That's one thing we don't think a lot about, is the other trades that are working around us. If we're producing a lot of airborne silica dust, we're not only responsible for our workers, but also their workers too. Blade and core segment cooling to protect tension of the blade. As we know, blades are tensioned to run straight and without wobble. Any undercooling could cause an unbalance in the blade. And then also the joint flushing to prevent the excessive abrasive wear or the core undercutting. This is especially known for during asphalt sawing. So we want to use water to flush. So this is one of the new products. It's called a flocculant. And what is a flocculant? It's a chemical blend of clay and polymer, and also acid blend for slurry treatment. So what this will do is it's added to the water. It will it's a special sodium bentonite clay that expands and creates a large surface area. It also creates a negative charge. It's actually a charged particle that the suspended particles in the slurry are positive charge, and they are attracted to and stick to the clay, and in turn become heavy, a heavy mass that actually causes settling and separation of the water and the solids. Another new product is super absorbents. These are products that have been in the industry for a few years. It's a super absorbent polymer. We call it a sodium polyacrylate. It's commonly used in the manufacturing of baby diapers. It's a super absorbent polymer that absorbs approximately 200 to 300 times its weight in water. And as the water molecule enters the polymer crystal, it's encapsulated, so it won't release the water unless by evaporation. So it's a very good way to solidify liquid water, and also the contaminants that are in the water. There's a few tests that the landfills are really concerned about. They will not and do not want to accept anything in a liquid state. We want to produce a non-flowable solid, and we also want to produce a solid that will not leach the contaminated water. In the U.S., we call that a paint filter test. It's a solids test. So after solidification, it can't revert back to a liquid state. It's also tested for what they call a T-clip, toxicity characteristic leaching procedure. This is where the product will, after absorption, it will not leach. And this is especially important in landfills, so that after it comes in as a solid, it stays as a solid, and it only dissipates by evaporation, and it entraps all the heavy metals. And we'll talk about that. Okay, what are the filtering options? So basically what we're trying to accomplish is we're taking the slurry product, we're creating a separation of slurry and water, and putting it through some type of a filtering process to trap the solids and allow the treated water to pass through, hopefully for reuse, or at least it's going to be ready for compliant disposal. Equipment available today, filter presses, as I mentioned. There's belt presses, there's centrifuges, there's hydrocyclones, and dewatering bags, or bladder style dewatering bags. These are all porous style bags that allow the water to pass through and retain the solids. So what's some of the problems with the slurry? Not only we have suspended solids, but we have pH, and pH is one of the most critical parts of the concrete slurry. You don't think about it. I'm sure everyone has had a slurry burn sometime in their days of sawing. It's a range. It stands for the power of hydrogen ion. pH ranges from 0, which is acidic, to 14, which is caustic, which is on the complete other end of the scale. And this is logarithmic. This isn't linear. So so the difference between a acidic pH of 1 to a pH of 2 is 100 times difference. pH 3 is 1,000. pH 4 is 10,000. You can see it rises very quickly. So normal water is a balance of around 7, and concrete slurry, you can see, ranges from 11.5 to 12.5. So we have a very high caustic solution of water, and this is what burns you. And this is the problem with disposal of high pH water. So you really need some kind of an acidic additive to bring down the pH down to a dischargeable level. Normally in the U.S., our ranges are from 9.5 to around 10.5, and that range is typically about where we can discharge. You can do it slightly higher in some applications if it stays on the property. And again, I mentioned the ICD contact dermatitis. This is the burn that you get by getting slurry on you, and what it does as it absorbs you may not feel it immediately, but later that night you're gonna feel that. So anything acidic on your skin, to wash your skin, number one, keep it off your skin. Number two, if you get it on your skin, you're best to use a slightly acidic product to help you neutralize it. And there are now some low pH hand soaps available for that. Okay, what is important to consider about suspended solids and heavy metals? Now, this is the stuff that again, this is what the landfill and the EPA in the U.S. Is most concerned about. We don't want this running into the creeks and streams. They enacted a rule in 1971, the Clean Water Act, with very specific rules on wastewater discharge, and we've got to follow those rules. And the suspended solids and heavy metals are the two main things. There's also the heavy metals. In that chart to the right, you'll see that we had done a test on concrete slurry. This happens to be from a washout pit at a ready-mix plant, but it's basically the same thing. This is actually worse. But you can see by before and after treatment, we're dropping out suspended solids down to a discharge rate. We're dropping the pH. We're able to pull out some of the oils and greases, and then also we're encapsulating and taking out a lot of these heavy metals, including chromiums and a lot of things that are in cement: mercury, chromium, potassium, cobalt, those kinds of products. Okay, so the Clean Water Act made it unlawful to discharge any pollutants, and these are just some of the rules of the EPA, and this is storm drain protection. So anytime on your job site, you'll want to protect the storm drains. So typically storm drains go directly into creeks and streams. So we want to protect that, and especially on bridge decks, something where, you know, it has access to the water. These are just some terms I'd like you to learn for future POTWs. This is what they refer to as the water treatment plant, publicly owned treatment works. Again, the pH is not as big a deal, but they definitely don't want the heavy metals, and they don't want the suspended solids. Okay, what did we do with the slurry? We collect it, we treat it, we filter it, and hopefully we recycle it and reuse it. You can use up to 50% of your water again if you're able to treat on the job site. And this could save you a lot of trouble on projects that have difficult water applications. What are the tools and techniques? We can use wet vacuums, auto scrubbers. Then we have containment things like bins and totes and drums. This is nothing new, but the concept is to mix, filter, and reuse on the job site if possible. Again, we've got drums, bins, and totes. One of the new techniques that contractors are using, especially in the concrete polishing market, is we're suspending these dewatering bags inside the dumpsters for large volume treatment, something, thousands of gallons per day. We can hang these bags into the line dumpster. We can drain or pump the slurry into these dumpsters in these suspended bags, and they'll dewater, and we'll actually be able to pump the clear water off the bottom of the line dumpster and put it right back on the job. When the bags are full, they just cut the straps, and the product's dry enough, it goes to landfill, and it's gone forever. So how is the commercial hauling of wastewater, and what are the risks? There's hauling permits required. We really don't want to be in the slurry hauling business. The perfect scenario would be to treat the water, solidify the solids, return the water to the sewer, and don't come home with any water. How has slurry management evolved over the last few years? Obviously, the flocculants and solidifiers designed for high pH. Because this is such a high pH product, it took special blends to get it to this level. Most of these products have evolved out of the oil field industry for processing of drilling muds, but these products are now designed to separate, treat, and help the filters work better in high pH applications. There's new equipment available, portable filter presses. We've got bins with bags, and other new techniques are coming on all the time. And again, we want to learn to process and leave at the job site. And this is the key point. For a fee, we would like to investigate the idea of not taking ownership of the slurry, but actually it belongs to the building owner, and they're either going to have to pay to have someone come get it, haul it away. If we can possibly offer a treatment solution on the job site, it's a possible extra income stream. And again, who is responsible for the collection and handling? It's all in the negotiation, but typically, if we pick up the slurry, we've got to either give it back to the generator, the owner, or we haul it home. And we do not recommend hauling it home, because now you become part of the chain of custody. With that ownership, any contaminants that were in the building now are brought back to your shop and intermingled with your other slurry. And if there's dangerous chemicals, PCBs, heavy metals, chromium, oils, and greases, all these products are now intermixed with your slurry, and now you own the hazardous waste. So one of our goals would be to reduce disposal by reducing the overall use of processed water. So theoretically, if we could reduce our water usage by 50%, that's 50% less disposal we have to manage. How can we contribute to the environmental protection and risk avoidance through management? Protect the worker and the company. Again, we don't know exactly what's in that concrete. It could be hazardous, as we talked about, PCBs, chromiums, heavy metals, lots of auto repair shops and manufacturing plants that we cut, trench, and drill holes. We don't know what's in that concrete, and we do not want to be responsible for exposing our companies to lawsuits. And again, we talk about we should be able to come up with a strategy to recover these environmental fees for processing on the sites. Just as As we see in the tire recycling business, when you get your tires changed, you're going to pay a small fee to dispose of your tire. If you get a battery changed in your car or truck, you're going to swap it out. You're not going to dispose of it. You're going to give it to them, and you're going to pay them a fee. And again, to repeat, do not haul the slurry back to the yard. Do not take ownership of this slurry and contaminate the company's property. We've seen this before where companies have had a disposal area in the back of their yards, and then when they're doing their environmental testing to sell the property, now they have to deal with the toxic or hazardous waste that might be in your pits. And really, there's really only three types of companies out there: concrete cutters, well, all contractors, really. Companies that are currently working on these high exposure projects. This would be something that would have the general contractor would have an environmental health and safety manager, and they budget for this, and they know it's in the requirements, it's in the spec. What do we do with it? We have to dispose of this properly, especially on these high profile projects. And then there's other companies that want to learn how to properly manage. They're attending this webinar. Manage the wastewater and see if it's an income generating opportunity. And then the third would be the companies that don't care about the slurry and basically are willing to take that risk of fine from illegal dumping. So there's your resources. I will tell you, there is a really good resource. CSDA's put together a very nice best management practices. So take a look at that, and there's a link there, and you can download and take a look at what they wrote. And it covers a lot of the same stuff we covered today. So I thank you for your time. It was nice talking to you. And yeah, if you have any questions, feel free to drop an email. You can drop onto the website and watch some videos. And if we do have time, I can do a quick demonstration. This would be a sample of our slurry sup. This is a blend of, like I said, the blend of the bentonite clay, granular acids for pH reduction, and then the polymers. What this does, again, it's designed specifically for high pH. Yes, sir.
Can you show it? There you go. Show it to the camera. There you go.
Okay, so I'm just going to add a small dose. These are very low dosage products. It takes about a quarter cup for a 25-gallon wet vacuum, or basically 100 gallons per pound. And I'm going to show you how this activates. See, one will mix and one we won't immediately, and you can see it's a heavy clay, so it really doesn't do anything until we agitate. So as we agitate this product, again, you can mix it inside your wet vac, your tote, your bin prior, but it must be mixed because the clay has to hydrate. It swells up, it creates a very strong pozzolanic charge, and in turn, it starts to build the flock. So you can see how it's starting to build, and then the clear water is starting to form on top. Now, this is what's going to be happening inside your wet vacuums or your bins or wherever your containment is. So you can see how quickly that falls out. So not only are we dropping heavy solids, but we're adjusting pH, and we're encapsulating the heavy metals and greases. So the more agitation you give it, the more chance it has for physical contact, these positive, negative charges on the material, and you can see the flock grows bigger and bigger, and you can see the clarity of the water and how quickly it falls away. So in that case, So this water, this is our ultimate goal. We would like you to resolve with this water, re-drill with this water. There's no reason to dispose of it. Let's reduce our overall use and separate it out. So you can see the clarity of the water is very good. Other than I just poured a chunk. But you can see, we're able to recover at least 50% of our water. And then our other product is our super absorbent clay blend, and this is made again for high pH. It reduces leaching, and what we'll do is when we can either go straight to solidification, or we can go through the two-step process with the flocculant. But what this does, this superabsorbent, this basically turns this liquid almost immediately into a solid. So now see, it's a solid. It's in a condition where it can be disposed of in a landfill. It's completely encapsulated. It's completely water-free, and it will never go back to a liquid state. You can see on it. It's dry. So that's the two products: a separator and a solidification. So that's what's new. That's what's new, and I hope it can help some of your sawing and drilling operations.